Good evening, sir. Um,
Hello everyone, how are you all?
Fine, sir. What's about
Fine,
you?
sir.
Yeah, I'm fine also. Thanks for asking. Can somebody please inform in the group that the class has started because I'm unable to paste the link here. It's not getting copied here at all today. I don't know why. Some kind of Zoom issues maybe. Hmm, Just let me announce. The session is live. Yeah, nothing is happening today. Can anybody please announce in the group? Hmm. All people are there in the group, WhatsApp group that you are recently in. Hello, am I audible?
Yes,
Yes,
sir.
sir.
Yes, please. Yeah. I am unable to at all means I don't know what to do.
Sir, I have shared the link.
Okay, fine. Just wait. Okay. But it can't be copied from here, right? From the Zoom. Do you know my WhatsApp number? Junaid,
Yes, sir.
can you send me it there?
Yes, sir.
Yeah, got it. Thanks for giving it to me. Yeah, thanks. Okay, yeah, done. Posted successfully. Thanks for the help. Both Junaid and Saurabh. Okay, yeah. How many of you have attempted the problem yesterday? Left view.
So I attended, but not successfully.
Okay, yeah, no problem. We will at least you tried.
I also attempt.
Who have successfully done the problem? Means only 2 have done and rest all were sleeping. 3, 4, 5. Okay, only 5 are there. Whoever have attempted, text me on the chat box. It does not matter how you have failed, but the thing is you should have tried the problem. From this week onwards, I will push you that okay, the code part is yours. Some of the codes I will give you, you have to attempt. 6, yeah, I think, yeah, with Trupti. Okay, only one has successfully done. So I guess how many? 1, 2, 3, 4, 5, 6. Okay, 6 persons have done till now, and rest. I think I have given you the entire logic yesterday. Am I correct? How to attempt the problem? Am I correct?
Yes, sir.
The logic part was clear or not? Tell me that. See,
Clear, sir.
the topics in which you are right now, these things are not easy for the first time, right? Don't think that you are on easy topics and you will just understand everything in one go. This is not possible. Keep on practicing, and this will increase your understanding on everything. I think the recursion part is somehow more clearer now than what we have discussed in the previous. Am I correct? Little bit also. Your recursion is more clear since we are discussing these things now with trees and everything. Okay, so let's do one thing. Let's try to take the code of the problem and see how can we do that. Okay, yeah. Give me a moment to set up everything. Okay, no problem. You can use it using queues also. So 7 people are there who have attempted the problem. Is it? At least 10 of you should have done that. Try na. हार जीत तो लगी रहती है man. Try तो करते रहना चाहिए. While I just have begun my coding in my engineering days, what had happened was that there used to be some problems that I took in one day, and in the next day the solution would come of it. Such kind of experiences I have got.
सर मैंने लेकिन थोड़ा चीटिंग किया क्यूज को है ना क्यूज का पूरा कोड नहीं लिखा
ठीक है, वो प्रॉब्लम नहीं है. क्यूज का तुम्हें जैसे भी हो, तुम्हें लॉजिक तो मालूम है ना क्यूज कैसे आता है. देयर इज नो इश्यूज ऑन दैट. ओके,
मन नहीं किया लिखने का
वो बात नहीं है, वो बात नहीं है. तुम्हारा जैसे मन तुम वैसे कोड करो. दैट्स अपॉन यू. इट्स कंप्लीटली अपॉन यू. मेक श्योर दैट या whatever you are doing is correct. There is no hard code rule that while I am solving a problem, I have to do it in a certain way. There are many ways. Okay, just okay, fine. So I have done it. I can show you a way. There can be your ways also. Okay. A problem may have a two-pointer approach, may have a binary search approach. Anything is possible. May have a dynamic programming approach. Anything is possible. Whatever I am doing on that, whatever my approach is, the thing is that should be correct. Okay. There is no hard code rule that if certain problem is being solved using one method, that cannot be solved using another method or any other thing. Fine. So let's begin coding our problem today. Okay. Let's say, was that a binary tree or was a BST? Was a binary tree, right? Am I correct? So yeah, this was the BST part yesterday. Whatever we have seen this was a BST part. Okay. So yeah, as of now, let's comment these things out. Comment these things out and let's go to our binary tree part here. Let's reopen this. Let's reopen this and yeah. What was it? The left view. Am I correct? Was it the left view?
yes sir
Okay, fine. Okay. So def left view, right? What we will receive here? Root. Fine. Okay, fine. So what we have supposed that what we will do here, what we will do to solve this problem, what we have discussed. Somebody tell. Yesterday.
So dictionary create करेंगे.
Okay, we will use something called dictionaries, right, to solve this problem. Where you want to keep it? Let's keep it outside the function. Okay, declared a global variable, that is dictionary. Fine. This will solve my problem. Fine. Now what shall I do? Okay. And let's keep something here. Let's keep an answer list. Okay, inside a list, let's say I want to store entire nodes that are coming inside the left view, right? Okay, fine. So what shall I do? What shall I do? First, let's suppose if the tree is empty. If the tree is empty, what will be printed? Will there be any node that will come inside the answer? Tell me that.
No sir.
So just return from here. Nothing to do, just return. Okay. Okay, fine. Okay, so the root will always be inside the answer. Am I correct? The root will always be inside the answer. The first node to be coming inside my answer is the root node. Am I correct? Let's draw a tree. What our current tree is. Okay, and we have just missed one thing, that is the right now. If I am standing at the root, I am at level 1. Okay, this is what I have to keep. Fine. So okay. If what we discussed, if for this particular level there is nothing, no key inside the dictionary. Let's say if L not in dictionary, then what shall I do? L not in dictionary. Print the root dot data. Then do what? Then do what? Increase the value of L by 1. Increase the value of L by 1, and next, where shall I go? Where shall I go?
Left of the root.
Okay, this part. Okay. If L is not inside the dictionary, I will be printing the data. Else, what shall I do? Increase the value of level by 1. Then what will I do? Then what will I do? I will go to the left child, right? The left subtree of my current node. Am I correct? So let's go and try to print the left view of what? Try to print the left view of what? The left subtree. How will I go there? Root dot left.
Root dot left.
Okay, fine. This part is done. Okay, once I have done this, once I have printed the entire left subtree, I will come back to the current node. Am I correct? I will come back to the current node. Am I correct or not? After I have done printing the entire left subtree, I will come back to my current node. So what shall happen there? What do you think?
सर रुक जाएगा वहीं पे सर, वापस नहीं जाएगा।
नहीं, फिर कहाँ जाना पड़ेगा? आप आ गए, फिर राइट सबट्री में जाना पड़ेगा ना?
यस सर।
ओके, देन व्हाट शैल आई डू?
सर ऐसे लिख देंगे सर।
Left view of the right subtree I have to print, right? If any possible answers are there into the right subtree, I will go there. Am I correct? Root dot right. Okay, everything I have explored. All the left view of the right subtree has been done. Left view of the left subtree is also done. Both are done. Now from here I will go back to the previous node. Am I correct? If I go to the previous node, I shall decrease the level by 1. Okay, and one thing I haven't done from here is that after I print the root data, I should insert into the dictionary. That's all. This part was left. Let's try it. Let's try our problem. Let's try our problem, and yeah, after this part is done, this part is done, let me comment this out. And what to do here? The left view I have stored where I have stored the left view inside the answer. Okay, now let's try this. Let's try this, how my answer will be coming. Okay, let me try this. Okay, I haven't called for the left view, right? The function should be called left view of that starts from the root. Okay, now let's do it. What had happened in Nodal dictionary reference before assignment? Anything that has gone wrong there?
सर वो मेरे इसमें भी आया था, जो ग्लोबल लेवल एनालिसिस
एल नॉट इन डिक्शनरी को की या ऐसा डिफाइन करना पड़ेगा ना, डिक्शनरी
सर वो
डॉट की।
जो फंक्शन बना है ना लेफ्ट व्यू, उसके पास ग्लोबल और एल लिख दो तो फिर हो जाएगा बराबर।
Oh yeah, correct. You have said it correct. That's why it's not working.
तो ऊपर ग्लोबल एल लिख दो।
एक तो नोट just wait, let me see who is making noise, man. Let me try. Okay, invalid syntax, sorry.
सर वो लेफ्ट व्यू जहाँ पे लिखा है ना उसके नीचे सिर्फ एक बार ग्लोबल और कैपिटल एल लिख दो।
या चल जाएगा वैसे भी।
और फिर नीचे सब एल हो जाएगा बराबर।
ये यूज करने की मेरे को आदत नहीं है ग्लोबल वेरिएबल्स। See, that's running. Okay. 1319. What's happening, man? How my tree is looking like? Let me.
सर
अपना आंसर प्रिंट कीजिए।
Okay, sorry. I have already printed the answer. Is it? That's why ना। इसकी जरूरत ही नहीं है। Printed the answer. इसकी जरूरत नहीं है, ठीक है? Already तो print कर ही दिया है। क्या जरूरत है? Okay, how my tree is looking like? Let's see that. How my tree is looking like? Okay, how my print tree is looking like? The root node, and then what is towards the left of root? 2. Is it correct? What is in node 3? What is in node 3? 5. Sorry, this will be 3. This is 3, this is 5. What is else? How the tree is else looking like? Node 2 dot left equal to node 4. What is node 4 here? 9, right? Next. Node 3 dot right equal to node 5. What is the value of node 5? 7. And next, what is there? Node 3 dot right equal to node 5. Node 2 dot right equal to node 6. Node 2 dot right equal to node 6. Here it is. What is the value of node 6?
4.
Yeah, 4. And what is it? Node 5 dot left equal to node 7. Node 5 dot left equal to node 7. Which one was our node 5? Node 1, node 2, node 3.
7.
And its left was what?
7.
This was 10. So am I
10.
getting the all the values? 1 is printed, 3 is printed, 9 is printed, 10 is printed. Everything is printed for the left view. First node of each level. Have I printed everything correctly? 1 is printed, 3 is printed, 9 is printed, 10 is printed. Have I done it correctly?
Yes, sir.
Done or not? Tell me. So let's have a dry run. What is happening inside our problem? Okay, this is the left view. This is the left view. Okay, what is my dictionary initially? Initial dictionary is empty.
Sir.
Yeah, बोलो.
सर वो लास्ट में एक लिस्ट अलग से प्रिंट हो रहा है एम्प्टी वाला।
अच्छा वो नहीं, वो सॉरी मैंने रीरन नहीं किया था, ठीक है, रीरन नहीं किया है, कर देते हैं। अभी नहीं हो रहा है ना, पहले किया था। आंसर जो मैं सोचा था आंसर में पूरा आंसर जो लिस्ट है उसमें सब कुछ स्टोर करके फिर बाद में प्रिंट करेंगे, बट एक्चुअली मैं तो पहले ही कर देता हूँ, ठीक है। सो इनिशियली my dictionary is empty. Fine. So okay, the L that we have defined can be accessed from anywhere, but inside the function, if you want to access this L, you cannot. Okay, for that you have to mention something called global. That okay, this variable is global. Okay, can be accessed from anywhere. How Python will recognize it? By this keyword global. Okay, always remember that if inside, suppose inside a method you are in, okay, and some variable is declared outside this, okay, outside this behind that, okay, you have to write a keyword for that, okay, that global, okay, which L is it, Python will not recognize, okay, that this particular L you are supposing to, this will Python will recognize only one thing, that okay, if I write without this global, I write this L, Python will assume that okay, new L is being declared here, some other variable called L has been declared only for this function, okay. Hello, am I audible?
Yes, sir.
Okay, see what happens. Actually, we are going some kind of off topic. Oh yeah, see, this L is what? Outside a function. This L is what? Outside a function as well as outside any class. Whatever variable we have that is outside functions, that is declared outside function or class, by default they are global. What are they? They are by default global. So yeah, this L I have declared outside a function as well as a class. So by default, it will be treated as a global variable. Now, suppose I don't give this keyword global, okay? So what will happen? Python will think that, okay, this L has been declared. If it is declared inside this method, this L is a local variable of this method. And this L cannot be accessed outside this function, okay? This has been declared only for this method left view. Getting it? So how can I access the global L that I want to use? I want to use this L and I don't want to create any other variable L. So what will I do? That okay, the global variable that I have declared, I will use it inside the left view function. So for that, I am writing a keyword global, that okay, the global variable outside the function that I have declared, I will be accessing that and I will be changing its value. Okay, so for that, I have to mention a keyword called global. Fine. Is this point clear? What we will do, what are global variables, and how we will access that inside a function. Is this point clear to you? Tell me that. Okay. So now see, first function. Initially, I am at this point, right? My root is here. So yeah, if root equal to none, return. Is it true for this? Right now, if my root is at 1, if root equal to none, return. Will it be true? Is this condition true? Is this condition
No,
true?
sir.
So what will happen? This entire if condition will be skipped. Now come. If L not in dictionary, is it true? Initially, my dictionary is empty. Value of L is equal to 1.
Yes.
So anything, any key 1 is inside the dictionary. Is it there? Any key inside the dictionary with value 1, is it present? Initially,
No,
the dictionary is empty, right? So what will happen? L not in dictionary. Is this condition true then? True or false? If L not
True,
in
sir.
dictionary, so this condition is true. So what will happen? What will print root dot data? Whatever.
Print root that.
So what will happen? What will be printed? Sorry, yeah. What had happened?
Sir, 1.
What will be printed? 1 will be printed. Fine. Now next come here. Dictionary of L equal to 1. What will be happen? What will be happening here? 1. Key 1 will be created with value 1. Okay. This part is done. A key with value 1 has been created. Okay. Now this if condition is done. Now what will happen? Tell me. Value of L was 1. Value of L was 1. Initially value of L was 1.
L increment.
L plus equal to what will happen? L plus equal to 1.
Sir, L increment.
Value of
by 1.
L will be increasing by 1, 2. Fine. Now my function call was of left view, I have called it on 1, right? Now see, left view root dot left. What will happen here? Yeah, Pradeep, tell me.
Sir, dic of L equal to 1 is there, no, sir?
Yeah.
What
So
will be the key value in that?
Sorry.
No, for that line, what will be the key value?
L, whatever is the value of L will be the key, okay, and 1 will be the value for the key. Getting it? Dic of L.
Okay. Got
Okay.
it, got it, sir.
Okay.
Every time we are increasing L value also, sir.
Yeah. Okay, now tell me what will happen for this left view root dot left. What will happen here? Left view root dot left. What will happen here?
That function call again.
Left view function will be called for what? Left view
Three.
function will be called for
Root left.
what is the root left? This
3.
point, right? 3. Left view, that for the subtree of 3, I will be calling the left view function, right? Okay, now new function, as per the laws of recursion, new function will be executed first. New function will be executed first. So this is a new function. Let's begin the execution from the start. See. Okay. Again, if root equal to none, is this condition true again? Root equal to none. Is it true or
No.
false? How many of you say it is false?
False.
False.
Okay, this is false, right? This condition is false. So what will happen now? If L not in dictionary, what will happen? If L not in dictionary, what will happen? Is this condition true? What is the current value of L?
Yes, sir.
Current value of L is 2. Not in dictionary. So nothing, no key with value, no key, 2 is inside my dictionary. So this condition is true. Print root dot data. What I have done? Printed 3. Printed 3.
So please repeat again.
Value of L is 2. No key, 2 is present inside the dictionary. So this condition is true. Print root dot data. What was my root? 3. So what is the data? 3. Print it, and then dictionary of L equal to 1. What will happen now? If this line is executed, what will happen? What will happen? Tell me. Dictionary of L equal to 1. Dictionary of L. What is the value of L? 2. Key 2 will be inserted with value 1. Getting it? Okay, till here it is done. Till here it is done. Now L plus equal to 1. What will happen? Value of L will be increased by
Again,
3.
increment by 1.
3. Okay, now and left view root dot left. What will happen here? Tell me.
Sir, view
Left view of
कॉल होगा और रूट डॉट
9.
लेफ्ट जाएगा 9 जाएगा.
Left view. What is the left child of 3? What is the left child of 3? 9. So left view of 9 will be called. Okay. So okay, new function as per the laws of recursion. This will be first executed. Okay. So this is a new function. Start the execution from the beginning. If root equal to none, is it true? Is it true?
Yes, sir.
It is true.
false, sir.
I am right now here at this function call with root equal to 9. So is this condition true?
No, sir.
Root
False.
9.
False. Okay, now next line. L is not in dictionary. Tell me, true or false?
True.
True.
Okay, true. Then what will happen?
Print 9.
Print 9.
Print root.
Print root data, that is 9, right? What is the data inside the root? 9. Print it. Now, dictionary of L equal to 1. That is, insert a key 3 with value 1. Done?
Yes, sir.
Fine. Now, L plus equal to 1. What will happen? Value of L increase it by 1.
4.
Done. Okay. Now call
L
left.
incremented by 1.
Now tell me, left view root dot left. What will happen here?
Left of none will be called.
What is the left child of 9? What is the left child of 9?
None.
None. So what will be called? Left view
None.
of none will be called, right? Okay, now new function call should be executed first. Start from the beginning. Root equal to none, true or false?
True.
So do what? Return as it is. Nothing to do. Return here. Execution, stop the execution and return to the previous function call. Getting it? Okay, now next. This part is done. Now what shall I do? Now tell me. Okay, now I am back where? I am back to the LV9, this function called, right? From at what point it had stopped? At what point, till what point this has got executed?
Left view root dot.
Left view root left, right? This is the point where this has been executed. Now I will, for this function, I will do what? Execute this time. Left view root dot right. What will happen? Left view root dot right. What will happen?
Left dot 4 will be called.
None रहेगा sir.
I am at right. See where I am right now, at 9. At 9 right now I am. So what is the right child of it?
None sir. None.
None.
Yes, sir.
Okay,
Left
so
view of one will be called.
left view of none will be called. Okay, and for this function call, is this condition correct? True or false? Root
True.
equal to none, again
True
true.
sir.
So return as it is
Yes,
to the
sir.
previous function. Return as it is.
True.
Okay. Stop the execution. Return to the previous function call. Done. Now what will happen? Both the left and right subtrees of 9 has been explored. Both the left and right subtrees of none has been explored. L minus equal to 1. What will happen?
L become 3.
The decrement
L become
L
3.
decrement by 1.
L becomes 3. Okay, L becomes 3. And where it will go? Where it will go? Okay, I guess one point we have missed. One point I have missed. It shouldn't have been this. Okay, yeah, it's done. No problem. L equal to 3, right? L becomes 3. Now what will happen? L has become 3. The function has got executed. The full execution of this function, is it complete? Tell me. Anything else left for LV of 9 to do?
No, sir.
Level, anything is left. So this is completed. My value of
sir.
L is 3, right? Go back.
Return to 8. 3.
Okay, go back. Return to 3, right? Level left V of 9 is complete. Let's return to 3. Okay, now I am here. So at what point 3 has been executed? Till here, I guess the LV of 3 has got executed. Now what it will do?
Left view
right.
root dot right.
Left view root dot right. It will call for left view of, what is the right child of 3? What is the
4.
right child of 3? 4, right?
4.
Okay, now what will happen? It has called this new function. Should be executed first. So execution will start from here. Root equal to none, true or false?
False.
False.
Root equal to, okay, root equal, okay, false. This part is false, right? Now next, if L not in dictionary, true or false? What is the value of L right now? I am
False. It is already in dictionary.
Already there sir.
already
L
in
equal to
dictionary.
3.
That means this 9 will be shadowing this. It cannot be printed. I have already printed the first node, right? Now what will happen? This part is false. Nothing to do. Come here. L plus equal to 1. What will happen? What will happen?
Oh, it
L
becomes 4
become
again.
4.
Okay, now what will happen? It becomes 4. Left view root dot left. What will happen? In both the cases, what will happen? Tell me in short.
Sir, none.
None.
आएगा.
It will return again to 4.
It will in both the cases, since the left, is there any left or right child of 4?
Sir, none हो जाएगा और फिर L वापस से 3 हो जाएगा.
Both the left and right child of 4 are none. So it will return to 4 as it is. Nothing to do, right? So once these two functions, left and right view of none, has been executed, these two functions are done. What will happen? Value of L will be decreasing by 1, by 3, and it will return to the previous function. That's all. Nothing else is there. This part is done. This
So,
part is, yeah.
sir, if it's not like कि अगर L की value अगर dictionary में नहीं है तभी ये execute होगा print dot data और ये
क्या?
सर समझ गई, got it.
Okay, ठीक है. Fine. Okay, so this part is done. And now till what point LB of 3 has been executed? Till this point, I guess the LB of 3 has been executed, right? Now what will happen? The last line will be executed. L, value of L will be decreased by 1. It will return to the previous function call. Okay. Now tell me till what point LB of 1 was executed? Till what value?
Root dot left, sir.
Root dot
Left.
left. Till at this point, the execution was halted because new functions were coming. So I have to execute them first as per the recursion. Then only I can come back here. Fine. Okay, this part is done. Now what will happen? What will happen for left view of 1? What will happen? It will execute this left view, go and explore its right subtree, right? If any possible answers are there into the right subtree of 1, go there and explore that. Okay, I am there. Left view of 5, what will happen? New function, execution to start from the beginning. If root equal to none, true or false?
False.
Okay, false. Skip this. Now this. L not in dictionary. What is the value of L right now? What is the value of L right now?
2.
Already inside the dictionary?
Yes, sir.
Yes, sir.
This is false. Now, L plus equal to 1. Increase the value of L by 1.
It's
Increase
3.
the value of L by 1 and left view root dot left. Any left child of 5 is there?
No, sir.
Yes, sir.
Okay, so if I call for the left child, what it will be? LV of none. So it will return as it is to the previous. Why? Because if I execute this, the first condition becomes true and it will return. It will stop the execution immediately of this function. It will return to the previous function. Okay. Okay, now LB of 5. This part is done. What will happen? Left view root dot right. What will happen here?
7.
Left view of 7 will be called.
Left view of 7 will be called, right? This part, yeah. Okay, now left view, new function, start the execution from the beginning. Start the execution from the beginning. Root none, true or false?
मेमम भाई तुम्हारा
False, sir.
म्यूट करो ना.
False, false or true? Root equal to none, true or false?
False.
False.
So what will happen? This will be skipped now. L not in, what is the value of L right now?
3.
False, sir.
So L not in dictionary, true or false? False.
False.
So L plus equal to 1, right? L plus equal to 1. Value of L, increase it by
4.
1 and what will be happening? Left view root dot left. Left view root dot left. What is the root left of
view
7?
of 10.
Okay, I am here, right? I am here. Okay, new function should be executed from the first. Root equal to none, true or false?
So true. Ni false.
False. Next,
False, sir.
if L not in dictionary, now see L not in dictionary. True or false? What is the value of L? 4. Inside, it is inside the dictionary.
No.
No sir.
So what I have to do? Print root dot data. Print root dot data. Print root dot data. Dictionary of L. Key equal to 4. 1 will be inserted and next. This part is done. L plus equal to 1. Increase the value of L. Now tell me what will happen. Left view root dot left, root dot right. Here. What will happen? Tell me. I am at this, I am standing here at this 10. What will happen here? Tell me.
So both are none, so it will return back to the 10.
How many of you agree with Shazia? That both the child nodes of 10 are none. So for both the cases, root left and root right, left view of root left and root root right, what will happen? Left b of none will be called. Left b of none will be called, and both will be returning as it is, because for both of them the first condition is true, right? The execution will be immediately stopped and they will return to the previous function call as it is. Okay, this part is done. Okay, for left view, root left, root right, we are done. What will happen? L minus 1, value of L will be decreased by 1. It will go back to the previous function call. Done. LB of 10 is now complete. LB of 10 is now complete. Fine. Okay, fine. LB of 7, till what point LB of 7 has got executed?
Left view of root dot left.
Is it true that, okay, till this point, left view of 7 has got executed? Now it will call left view root dot right. So what is the root right of 7? What is the right child of 7? None, right?
None.
Nothing is there.
It will
So
back.
LB of none will be called. It will return as it is to the previous function call. That's it. And execution will be stopped immediately. Okay, now LB of 7, both for LB of 7, both these functions are called. Now L minus equal to 1. Value of L will be decreased by 1. It will go back. It will go back where? To the previous function call. Now till what function, till what point LB of 5, this left B of 5 was called? Till what point, sorry, this LB of 5 was been executed?
So left view of root dot left.
Till here, root dot right. 7 was there, right? The right child. So root dot right got executed. And then what will happen? L minus equal to 1.
So yes, come to.
It will be 2 and it will be going back to the previous function call, right? This got completed. It will go back to the previous function call. Now, till what point LB of 1 got executed? Till what point the left B of 1 has got executed? Both the left and right subtrees have been done. 3 also done, 5 also done. True or false? Both are done, right? Both the left and right subtrees we have explored. L minus equal to 1, L minus equal to 1, and returned from here. Wherever this function has been called from, return from there. And what final answer we have got? 1, 3, 9, 10. Tell me now what confusions you are having. Have we successfully printed our answer? Tell me
सर
that.
अगर हम L minus 1 नहीं करवाएंगे तो क्या होगा?
तुम्हारा लेवल चेंज नहीं होगा. लेवल जहां भी मैं
रिटर्न
खड़ा
तो
हूं,
हो रहे हैं ना सर, रिटर्न तो हो रहे हैं.
रिटर्न होने के बाद क्या हुआ? पर एल तो ग्लोबल है, उस वैल्यू को तो चेंज करना पड़ेगा. एल को तो मैं अंदर से कर रहा हूँ ना, अंदर से कंट्रोल कर रहा हूँ.
सर अगर L माइनस नहीं करेंगे तो फिर वो L नॉट इन एक वाला
फिर गलत से गलत आंसर आएगा, क्योंकि एल का वैल्यू चेंज ही नहीं हो रहा है ना. मैं तो करंट मेरा, मैं जब भी चेंज हो रहा हूँ, प्रीवियस नोट्स पे जा रहा हूँ या नेक्स्ट लेवल के नोट्स पे जा रहा हूँ, मेरा लेवल चेंज हो रहा है. For that, I am constantly plus and doing the addition and subtraction on value L. Okay, that whatever level I am at currently, okay, so I will be my else value will be matching that. Something like that will be happening.
Sir, we are also storing that value in dictionary.
Yes, we are storing the value in dictionaries. That okay, whenever I will be just hitting, whenever I will be just hitting a new level such that inside the dictionary that level is not stored, it is guaranteed that that particular node is the first node of the level. So print its data. This is my target. Okay.
Got it, sir.
This is the target.
हेलो सर.
बोलो.
सर राइट व्यू के लिए जो नीचे रिकर्जन के लिए लेफ्ट व्यू रूट डॉट राइट है उसको ऊपर लेंगे और लेफ्ट व्यू रूट डॉट लेफ्ट के लिए नीचे लेंगे ना.
एकदम. For the right view, if you want to print the right view, just take this line above this. Just take this line above this and you will be getting your answer.
सर टॉप व्यू के लिए,
टॉप व्यू का थोड़ा सोचो. एक्सट्रीम राइट एंड एक्सट्रीम लेफ्ट, ये जो एजेस पे एकदम एज पे जो बना हुआ है वही प्रिंट करना है, और बस ये रूट का जो वैल्यू है एक बार प्रिंट होगा. ओके.
यस सर.
आई थिंक वो भी हो जाएगा, वो भी मिल जाएगा. करो सही से तो वो भी हो जाएगा.
तो क्या लॉजिक लगाएंगे?
बता, एक तो रास्ता तो दिख गया, लेफ्ट व्यू कैसे प्रिंट करते हैं. सिमिलरली सोचो कि राइट व्यू कैसे प्रिंट करेंगे, बस लेफ्ट और राइट का कॉम्बिनेशन कर दो तो टॉप व्यू भी आ जाएगा।
सर लेफ्ट, अच्छा
ठीक है, नाउ टेल मी व्हाट डाउट्स यू आर हैविंग फॉर दिस प्रॉब्लम।
दो फंक्शन बना के लेफ्ट व्यू और राइट व्यू बना के दोनों को फिर एग्जीक्यूट करेंगे तो दोनों साथ प्रिंट हो जाएगा टॉप में।
उसकी जरूरत नहीं, टॉप व्यू तो सेपरेट है ना, लेफ्ट और राइट का कंबाइंड आंसर आएगा उसमें। अगर टॉप व्यू प्रिंट करते हैं दैट मींस यू आर सीइंग द नोट्स फ्रॉम द टॉप, यू आर सीइंग द नोट्स फ्रॉम द टॉप, सो योर आउटपुट शुड बी 1 3 5 9 7। ओके, these things should be printed। एक्सट्रीम लेफ्ट पे जो नोड्स है, एक्सट्रीम राइट पे जो नोड्स है वही दिखेगा बस। ठीक है, थिंक ऑफ इट।
सर ये 13597 होगा, ये 13957 पहले पूरा लेफ्ट फिर राइट, या फिर
कुछ भी तुम्हारा नोट्स प्रिंट करना है तुम आप किसी भी ऑर्डर में कर सकते हो उससे, वो बात नहीं है, ऑर्डर शुड नॉट मैटर हियर मच। थिंक in that terms, okay, that whether I am printing all the nodes or not, first have that approach। tell me that is everything clear with the left view?
सर लेफ्ट व्यू में लेफ्ट प्रिंट होता है और राइट व्यू में राइट।
obviously if I want to print the right view my answer will be 157 157।
कॉम्बिनेशन करके कर सकते हैं ना हम टॉप व्यू में।
हाँ तो देखो सारे टॉप व्यू का नोट्स में क्या आएगा, आंसर क्या आएगा 13957। सो 1 तो कॉमन हो गया, 39 लेफ्ट व्यू से आ गया, 5957 क्या है राइट व्यू से आ गया, दैट्स ऑल। ये टॉप व्यू का आंसर होगा।
राइट व्यू का आंसर क्या आएगा सर?
157, सॉरी 157 10 आएगा।
और जब
Only
हम टॉप
टॉप व्यू में क्या बोला मैंने, एक्सट्रीम एज पे आएगा, एकदम टोटली लेफ्ट पे जो है और टोटली राइट पे जो है, ये जो नोड्स है ये नेग्लेक्ट हो जाएंगे, नहीं दिखते, नहीं दिखेंगे हमें।
जो कॉमन है उसे रिमूव करना होगा।
नहीं रिमूव नहीं करना पड़ेगा, जो एक्सट्रीम एज पे है, टोटली राइट पे है और टोटली लेफ्ट पे है, ऐसा नहीं कि लेफ्ट में जाते जाते फिर राइट चले गए, ऐसा नहीं होगा। टोटली लेफ्ट में जो नोड्स हैं, टोटली राइट पे जो नोड्स हैं, उन्हीं नोड्स को मैं प्रिंट करूंगा, नहीं तो करूंगा ही नहीं। दिस इज द लॉजिक फॉर टॉप व्यू।
सर यानी कि जो 4
सॉरी
4 और 10 प्रिंट नहीं होगा ये ट्री के लिए।
नहीं 4 और 10 बिल्कुल प्रिंट नहीं होगा। 4 तो इंटरनल नोड हो गया ना, लीफ नोड्स कुछ भी हो वो प्रिंट नहीं होंगे एक्सेप्ट द नोड दैट इज ऑन द एक्सट्रीम एज। 9 भी लीफ था ना,
लेफ्ट से जितना लेफ्ट साइड ही रहेगा वो होगा, या राइट साइड से
या एग्जैक्टली, कीप ऑन गोइंग टू द लेफ्ट or keep on going to the right, whatever nodes you are getting those will be the part of the answer for top view।
लेफ्ट
little
व्यू
bit
में तो फिर 10 भी इंक्लूड हो जाएगा अगर लेफ्ट व्यू को
हाँ,
रन करेंगे तो।
लेफ्ट व्यू देखेंगे तो 10 भी इंक्लूड हो जाएगा, क्योंकि मैं लेफ्ट पे खड़ा हूं मुझे 10 तो दिख ही जाएगा विदाउट एनी डिफिकल्टी। राइट
सर
पे
राइट
खड़ा
व्यू
हूं
से भी दिख जाएगा।
दिख जाएगा, बट अगर ऊपर से देखूं तो ये इसको क्या 5 जो है इसको कवर अप कर देगा, बिकॉज 10 जो हो रहा है स्लाइटली इंटरनल है, एक्सट्रीम एज पे नहीं जा रहा है, दैट्स ऑल। Tell me any problem you have for the left view part? Or is everything clear with this problem? Now I guess you should be able to do the right view. I think and slight changes. This line, if you take it to the above, this will do the above the root dot left, this will give you the right view. Now combine those things, slight changes will give you the top view. Okay, tell me, any doubt you are having? Any doubt? Shall I move ahead?
Yes, sir.
Sure. How many of you say? Okay, fine. Let's move ahead then. And I guess, yeah. Let's take another problem from BST, then I will move on to the heap part. Okay, one problem from BST. You are given a, let's say you are given a BST. You are given a random tree. Let's say you are given a random tree, random binary tree. Validate, you have to validate, check whether the given binary tree is a BST or not. You have to check. Think how will we solve this problem? 2-3 minutes, then I will share the approach. You are given a binary tree. Okay, a random binary tree will be given to you. Suppose like this. Check whether the given binary tree is a BST or not. Is a BST or not.
सर ट्रैवर्स करके वैल्यूज कंपेयर कर सकते हैं.
सर लेफ्ट हो गए अभी.
Hello, sorry. Actually got disconnected for a while. Let me share the screen. Yeah, take this problem. Yeah, tell me, Junaid, what's the problem?
सर प्री ऑर्डर से कर सकते हैं ना कि नोड पे लेफ्ट राइट चेक करें.
कुछ भी करो. That's your choice.
हम वैल्यूज कंपेयर कर सकते हैं फिर.
एनी आइडिया यूज करो, जो भी अच्छा लगे। मुझे बताओ कि कैसे आएगा ये आंसर। टेक 2-3 minutes, think, then we will discuss.
Hello, sir.
Yes, tell me.
Sir, we can create an empty state and print the in-order traversal of the tree. And if it is sorted, we can say it as BST or it's.
Okay. Okay, fine. One thing. See one thing. Let me take this tree. Let me take this tree. What is the pre-order traversal of this? 2, 2, 5, 6, 6. This is also sorted, right? Can you say this is a BST? Is it a BST?
No, sir.
Okay, so something, these cases should be taken care. These cases should be taken care. Think of it, few minutes, then we will discuss.
सर प्री ऑर्डर में तो पहले 5 प्रिंट होगा ना?
तो इन ऑर्डर ट्रैवर्सल देखना पड़ता है ना कि वो सॉर्टेड है या नहीं इन ऑर्डर में. Sorry, I guess, yeah, I was meaning in order, not pre-order. In order is always sorted. In order is always sorted.
Yes, sir.
Sir, why that is not a BST?
Can a BST contain duplicates? I think we have discussed the properties. Left subtree, if there is a node,
Yeah, okay.
okay, this
Yeah,
should
it
be,
has to be minimum and but
yeah, right. जुनैद और कुछ है?
सर ट्राई कर.
करो.
हेलो सर, हम लोग स्टैक यूज कर सकते हैं?
कुछ भी कर सकते हो,
मतलब सर स्टैक यूज करेंगे,
कुछ भी, whatever you want, you can.
उसको अपेंड करेंगे, फिर
Any approach you got? Any idea? This question is also in your CC. For previous days, this question is also in your CC. Okay, 2 hints I will give you. 2 hints. Two hints. 2 properties you have to utilize. If this is my BST, 2 properties you have to utilize. This is 5, right? This is 5. Can any node from the left subtree greater than 5? True or false? Any node from the left subtree, can it be greater than 5? True or false?
False, sir.
So I can say
False.
for this tree to be a BST, for this tree to be a BST, greatest node, greatest value node, greatest node should be greatest node from the left subtree of 5. Left subtree of 5 should be lesser than 5. Am I correct? The greatest node from the left subtree of 5 should be lesser than 5. Is it correct or wrong? Tell
Correct,
me.
sir.
As well as second property is what? The smallest node. The smallest node from the right subtree of 5 should be greater than 5. Am I correct? Smallest value node from the right subtree should be greater than 5. Am I correct? All the nodes from the right subtree of 5 should be greater than 5. Mandatory. Am I correct? This is a mandatory thing. So whatever is the smallest value of node that I have inside the right subtree should be greater than 5. Mandatory. These 2 things are the key to solve this problem. And these 2 things are recursively true for all nodes. For all nodes. How will I do this? Greatest node in the left subtree of 5, greatest value of node, that is this 4, should be lesser than 5. Least value node from the right subtree should be greater than 5. These 2 conditions you have to utilize. How will you do it? Any idea? And this is this part. For each node, this is true. For each node, this is true. So anyhow, using post order traversal, I can do this. Anyhow, what do you think?
Sir, we take a Boolean value true and we return it if we find the conditions true.
That's true, but how will you do it? What will you do first? One thing you can do is that if this is the tree. So what I said, for each node, that means each of the subtrees I will check. At first I will check whether the left subtree of 5, is this a BST? And also again I will check for the right subtree of 5, is this a BST? If both of them are BSTs, then I will somehow find out what is the greatest value here in the left subtree of 5. Greatest value in the left subtree of 5. And I will find out what is the least value from the right subtree of 5. What is the least value? Then I will compare with 5. That okay? If the least value from if the greatest value from the left subtree of 5, if it is lesser than 5, and if the least value from the right subtree of 5, if it is greater than 5, if this is true, then combining both, I will return true. Else I will return false. Else false. Okay. Try to solve this problem. Code it somehow. Using post order traverses, whatever techniques we have used till now, try coding this. You will get your answer. First check whether the left subtree is a BST or not. Then check whether the right subtree is a BST or not. Try calculating what is the greatest value in the left subtree of 5 and calculate what is the least value in the right subtree of 5. If the greatest value in the left subtree of 5 is lesser than it, and if the least value from the right subtree of 5, if it is greater than 5, then only I can say the entire tree, if the entire tree is a BST. And it should be also there that the left and right subtree both are BSTs. Both the left subtree and right subtree of my given tree of 5 should be BSTs, mandatory. Else, if any of the condition fails, the answer is false. Using recursion, you will be able to do this easily. And post order traversal. Nothing else will be required. Try solving this problem. Code it. I think surely you will get your answer using the methods till now whatever we have used. Okay. Understood how the approach will be using post order traversal? Tell me that. Is the method clear? How we will utilize the post order traversal? So we'll check first recursively if the left subtree of 5, if that is a BST or not. Then I will calculate what is the greatest number inside the left subtree. If it is lesser than 5, okay. Then I will go to the right subtree, check whether that is a BST or not. We'll calculate what is the maximum number. What is the maximum number? What is the minimum number inside the right subtree? If the minimum from the right subtree is greater than 5, then okay, fine. My entire tree is a BST. This method should be utilized. Can you try it? Tell me that. Can you try that? Have some response, man. Again, a pin drop silence.
Yes, sir.
Only one person is saying that is true in a very odd voice. And one person is texting. I think Mahesh has only told me. Is it?
Yes, sir, we'll try this.
Okay.
Yes, sir. Right, sir. Try.
Yeah. Okay, let's move on to our new topic. That is heaps. That is heaps. Interesting topic. Okay, anyone knows anything about heaps? What is a heap?
Sir, ढेर यही पढ़ा है बेटा.
Chalo, heap. Good definition. ढेर. What is the ढेर? ढेर क्या होता है?
Pile something and pile up and make a yeah, kind of this.
तो ट्री को भी हिप ही बोलते हैं.
नहीं, ट्री, हर ट्री को हिप नहीं कहते. Okay, see, heap is what? First definition, heap is what? Binary tree. First thing, heap is a binary tree. What kind of binary tree? Complete binary tree. What kind of binary tree is it? Complete binary tree. Will you remember this? Can you remember these 2 points?
Yes,
Heap
sir.
is what? A binary tree. What kind of binary tree? A complete binary tree. Till now, BST. BST was a complete binary tree. Was it true? BST was a complete binary tree. BST is a complete binary tree. Is it true or false?
Maybe it can be or it cannot be.
Acha, tell me one thing. Is this a BST? Is this a BST? Tell me that. Is this a BST?
Yes,
Yes, sir.
Yes, sir.
Yes, right. So is this a complete binary tree?
No, sir.
Complete binary tree means all the levels will be filled except the last level. A last level may be or may not be filled. This is a BST, right? But not a complete binary tree. What is a heap? What is a heap? A complete binary tree. First definition. complete binary tree. Okay, that means all the levels of my tree, binary tree, will be filled. All the levels will be completely filled. All the levels will be completely filled except the last level. Last level may or may not be completely filled. Getting it? Tell me that. Is this definition clear? What is a heap?
Yes, sir.
And what is a complete binary tree? BST may or may not be a complete binary tree. It is definitely a binary tree. Binary search tree is 100% a binary tree. This is true, but it may or may not be a complete binary tree. But when it comes to heaps, heaps is 100%. Whenever I make a heap, 100% that will be a complete binary tree. Okay. Is this point clear to all of you?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, now let's move ahead. There are two kinds of heaps. There are two kinds of heaps. One is the min heap. One is the min heap. And another is the max heap. What does my min heap tells me? What is the meaning of a min heap? Min heap tells that let's make a tree. Let's make a tree. How many levels you want inside the tree? Tell me. Complete binary tree. Heap is a complete binary tree. How many levels you want to make?
Minimum 2 set.
3, sir.
चलो 3 ही का बनाते हैं अभी, ठीक है?
सर वो ट्राई रन करने के लिए इजी होगा.
तो परफेक्ट बाइनरी ट्री भी हो सकता है.
हो सकता है, कोई प्रॉब्लम नहीं है. Okay, so min heap says all the nodes I have should be greater than the root node. Getting it? Any of the node inside my tree I have should be greater than my root node. The root node will be the smallest in the entire tree. Getting it? Getting it? And root is smaller than all nodes, all other nodes of the tree. This point is true for all nodes. What do you mean by this? Root is smaller than all other nodes inside the tree, inside its subtree rather. This point is true for all nodes. Okay, fine. Let's have an experiment and we will see. Root is smaller than all nodes. Let's say my root is 1. I want to insert okay, say let's since the fact is okay, root should not be the smaller, root should be the smallest. Okay, root should have the smallest, but let's modify the definition a little bit, because in heaps we don't have any concept that we cannot have duplicates. We can have duplicates. Root should have the smallest value. Okay, the smallest value among all nodes. And this is recursively true for all nodes. Recursively true for all nodes. Can anybody explain me this? Can anybody explain me this? Recursively true for all nodes. What do you mean by this?
सर जैसे लेफ्ट सब ट्री का जो रूट रहेगा वो भी स्मॉलेस्ट होना चाहिए पूरे लेफ्ट सब ट्री में.
Exactly. Root should have the smallest value. Okay. This condition should be true for all subtrees. If I am considering the left subtree of 1, it says that okay, inside the left subtree this node should have the smallest value. Getting it? This node should have the smallest value. Similarly, if I am considering the right subtree, this particular node should have the smallest value. Getting it? This is the meaning. Okay, fine. Let's see. Let's say one is the node of my entire heap. Fine. One is the root of my entire heap. Now, let's say I place it 2. I place 2 here. Can I place 2 inside the left child of 1? Can I place 2 inside the left child of 1? Okay, fine. Can I place 1 inside the right child of 1? Is it anyhow? Say that, okay, this definition is not again matching, or this is not satisfying. Even if I place 1 at the right child of 1, does it violate anything? Does placing 1 as the right child of 1, the root node, violate this definition? Is it true?
Yes sir, violating करेगा.
कैसे करेगा?
No,
बताओ.
so it is still smallest.
1 is still the smallest, right? 1 is still the smallest among the entire tree. Value तो वही है ना, smallest है. 1 को मैंने रख भी दिया तो क्या? ऐसा तो नहीं. Okay, suppose that if I place 0 here, will it now violate
Yes
the
sir.
definition? Why? Why
Yes,
is it?
sir.
Why it will
0
violate?
is less than 1.
0 is less than 1, right? And 1 should be the smallest, should have the smallest value in the entire tree. Entire tree में जो भी nodes होंगे, 1 की value जो भी root में मेरा है, root में जो भी मेरे पास value है, that should be the smallest. Doesn't matter even if I place it several places also. Even this 1 is present in any other node also, no matter at all. Okay, no matter at all. But 1 should be whatever value that I have inside the root, that should be the smallest value in the entire tree. That should be the condition. So even if I keep 1 into the right child, into the left child of 1, into the right child of 1, again, no matter, 1 is still the smallest value of the entire tree. So I can keep it, no problem. Okay, and again see, 2 is greater than 1. 2 is greater than 1, and that is kept at the left child, and the right child is smaller than 2. Value of the right child of root is smaller than 2. No problem, you can keep. This property should not violate, that's all. Okay, now let's say I want to keep 3 here. Will it be causing any problem? Any roots? Any violations in the definition have been there? And I kept 5 here. Now tell me, is this a heap? Is this a min heap? My min heap is looking something like this. 1, 2, 3, 5. 1, 1, 1.
True sir.
Now tell me,
Heap.
is it a heap? Is it a min heap?
Yes sir.
How? Okay, let's see. Entire tree, come to the entire tree. Entire tree. Is the root having the smallest value?
Yes sir.
Is the root smallest possible value inside the tree? Root is having that?
Yes
Root
sir.
is having that. How many of you agree with me here? Root
Yes,
is
sir.
having
Yes,
the
sir.
smallest
Yes, sir.
possible value. Okay, now let's come to the left subtree of 1. Left subtree of 1. Left subtree of 1. Left subtree, what will be the root of the left subtree?
2.
So inside the subtree of 2, root is having the lowest possible value?
Yes sir.
2, 3, 5. What is the subtree of 2? 2, 3, 5. Lowest value is present at the root. True or false?
True sir.
True.
Okay, now again, let's come to the left subtree of 2. Only one node. Lowest possible. True or false?
So true.
Only one node in the right subtree of 2. True or false? Lowest possible value. True or false? Next, let's come to the right subtree of 1. Right subtree of 1. Lowest one. The right subtree. What is the right subtree? Root of the right subtree? What is the root of the right subtree?
1.
is the root having the lowest possible value in its subtree? Lowest possible value in the subtree, the root is having. Why again silence, man?
Yes,
1 is
sir.
the lowest
Yes, sir.
possible value, and again left subtree of 1, left subtree of this one, lowest possible value.
Yes, sir.
Yes, sir.
Right subtree of 1, lowest possible value.
Yes, sir.
So I can say the entire structure has, for each node, this definition is correct. So I can say, okay, this structure is a heap. Getting it? For each subtree, for each of the subtree as well as the entire tree, the root should have the lowest possible value among all other nodes of the tree. Getting it? What is the meaning of the definition? Have you got it? Tell me that now. Or any doubts you are having? Again, a pin drop silence. Yeah, tell me, Kanu, what is the doubt?
सर शुरू से समझा नहीं ठीक से।
चलो और भी एग्जांपल लेते हैं।
सर एक बार रिपीट कर दीजिए।
चलो एक और एग्जांपल ही लेते हैं। Yeah, we'll take another example. Okay. Let me make a tree. Let me make a tree. 1, 2, 3, 4, 5, 4, 5. Let's say. Okay. Let's start from the root. Values of the entire tree. Consider values of the entire tree. Lowest value is present at the root.
Yes, sir.
True or
Yes, sir.
false? So what was
True,
the
sir.
definition? What was the definition of min heap? What was the definition? Root will have the lowest value among all other nodes. And this is recursively true. Recursively true for all nodes. For all nodes of the tree. Okay, so let's start with the main root of the tree. Okay, main root of the tree. Lowest value that is in that inside the tree is present at the root. True or false?
True, sir.
Okay,
True.
fine. Let's explore the left subtree of 1. Left subtree of 1. What is the left subtree? 2, 4, 5. Lowest value of the left subtree is situated at the root. Am I correct?
Yes, sir.
Yes, sir.
Okay, fine. Let's come to the left subtree of 2. Lowest value of the left subtree of 2 is situated at the root. True or false?
Yes, sir. Because it's only
one node, so lowest and maximum everything will be inside this only, right? Fine. Now next, lowest value of the right subtree of 2 is situated at the root only. True or false? True, right? Whatever, only one value, no point of comparing anything. So okay, entire left subtree of this binary tree, entire left subtree of 1 is a heap. That's confirmed. Now let's check for the right subtree of 1. Right subtree of 1, 3, 4, 5. Okay. For the right subtree of 1, lowest value is present at the root. True or false? For the right subtree of 1, lowest value is present at the root.
Right. Yes, sir. 3.
Okay, so let's go here. Left subtree of 3, lowest value is present at the root, and right subtree of 3, lowest value is present at the root. True or false?
True, sir.
Okay, so the right subtree is also satisfying the nature of heap. So can I say the entire structure is a heap? Why it will be? For each node I have checked that okay, their respective for each node inside their respective subtrees, what we have got, the lowest values are residing at the root. Okay. For each node inside their for the respective subtrees, the lowest value is present inside the roots. Okay. So that's why the entire structure is called heap, called min heap, not heap only, min heap. For each node, root will have inside its entire subtree, the root will be having the lowest possible value. Among all value, roots will be the smallest. And this is recursively true for all other nodes. So if I mean for all other nodes, that means you have to check inside their subtrees, okay, that whether that particular node is having the smallest value inside their subtrees or not. This is necessary. Any doubt here? Any doubt here?
No, sir.
All done?
नो सर. सर अगर ये हम लोग हीप का पहले प्रॉपर्टी पढ़े थे कि ये बीएसटी होना चाहिए, बट ये एग्जांपल में तो ये बीएसटी नहीं हो रहा है ना.
बीएसटी नहीं होना चाहिए, कंप्लीट बाइनरी ट्री होना चाहिए. बीएसटी क्यों होगा ये? मैं तो बोला कंप्लीट बाइनरी ट्री होना चाहिए. बीएसटी तो नहीं भी हो सकता है. ठीक है. This is the binary tree, and what kind of binary tree? Complete binary tree.
Complete binary tree. Okay sir.
तो ये तो complete binary tree है ना, देखो है कि नहीं?
नहीं सर, मेरा दिमाग में चल रहा था कि बीएसटी होना चाहिए, इसलिए.
बीएसटी नहीं है. ठीक है. Okay, now somebody can you give me the definition? What will be a max heap? What will be a max heap? Whatever we have discussed.
The maximum value.
What is a max heap?
Root has the maximum.
Root has the maximum value. What does it mean?
Recursive.
Among all nodes, right? And one thing, what else should be there? What else should be there? This is the point 1, right? Point 2 is recursively true for all nodes. Okay, these two points should be there. Maximum value should be at the node and recursively true for all nodes. Getting it? So, okay, can anybody tell me, is this a max heap? Is this a max heap?
Yes, sir.
Why?
Yes sir.
Why?
All have the maximum number 7.
And for each subtree also, I say, if this is the subtree I want to see, root is having the maximum value. Am I correct? Subtree's root is also having the maximum value. No, inside this subtree, you cannot find any node that is greater than 7. Okay. So this subtree, every subtree of this tree satisfies the criteria. And as well as the main root of the tree is also having largest possible value among all other nodes. So we can say that, okay, this structure is a max heap. Any doubt you are having with what is a heap, what is a min heap, and what is a max heap? Tell me that first.
No sir, clear.
Who is having doubt? Ask first.
It's clear, sir.
Only 3-4 people, I guess. 5-6. I guess 7. Eight. Okay, how do we represent? How do we store it? How will we make this tree? How will we make this tree? Any idea? Min heap I want to make. Suppose that this min heap I want to make 1, 2, 3, 4, 5. I want to make this. How will I make this? Any idea? What can you think of probably? How will we make this min heap? Don't be in a pin drop silence mode, man. This is not a school. Nobody is speaking. Why? Haven't you read?
Actually, I don't understand.
Means how will you create this heap? How do, means what do you understand? What is a heap? Haven't you understand this?
Has taken.
Okay, see one thing. Okay, class and all. Using classes and all, can we make it? Classes create a node and assign left and right child. Can I do that?
Yes, sir.
But I say this is not required for heap. This is a complete binary tree. See, complete binary tree. Make an array. Make an array. Make an array. Insert like this. Whatever I'm saying. How many nodes are there? 5. Okay. Okay. If this is a complete binary tree, leave it part. Leave that part. Okay. Let my root is at the first index, is at the 0th index of the array. Okay, left subtree. What is the root of the left subtree?
2.
Okay, insert it. What is the root of the right subtree?
3.
Okay, keep it here. Okay, what is the root of the left subtree of 2?
4.
What is the root of the left subtree of 5? Okay.
5.
Okay, now see. This is the main root of the entire tree. 1. Its child are at 2 and 3, 4. Getting it? Sorry. Its child are 2 and 3. So 2 is, if this is 0, 2 is residing at index 1, 3 is residing at index 2. Getting it?
Yes, sir.
Okay, now see. Child nodes of 2 is residing at index 3 and 4. Am I correct? Am I correct?
Yes, sir.
Okay, fine. Hello. Okay, now say, if there is a node I, if there is any number present at the ith index, if there exists any node at the ith index, it has child nodes at 2 into I plus 1 and 2 into I plus 2. These two slots will be the child nodes of I. Getting it? Match it. If you want, you can match it. Zero is the root of entire tree having child nodes at 1 and 2. 0 is the root. 0th index is having root of the entire tree. It will be having child nodes where? It will be having child nodes at what index? 2 into I plus 1. Tell me, what is it?
1 and 2. 1 and 2.
Is it there? 2 and 3. I have placed it there. Have I placed it correctly? Okay, now.
Yes, sir.
1 will be having, now index 1 will be having where? Index 1 will be having at what indices the child nodes of 1 will be there? 2 into 1 plus 1, 2 into 1 plus 2. So what are the what values I am getting here? 3 and 4. So child nodes of 2, is it placed at 3 and 4 correctly?
Yes, sir.
Had I add 2 more nodes, 6, 7. Add 2 more nodes, 6, 7. And place them again here. 6, 7. Now do one thing. So if for index 2, it should have child nodes where? Calculate. For index 2, child nodes should have been where? Should be where?
5 and 6.
Should be at
Five
index
and
5 and 6. How? 2 into 1 plus 2. 2 into 1 plus, 2 into 1 plus 1 and
2 into 2 plus 1.
Yeah, exactly. 2 into 2 plus 1 and 2 into 2 plus 2. So what is the value? 5 and 6. So if any node is present, if any node n is present at the ith index, at index I, it will have child nodes present where? If it will have child nodes present where? At 2 into I plus 1 this index and 2 into I plus 2 this index. Left child will be present at this node, right child will be present at this node. Getting it? How heaps are made? You have to just maintain an array, nothing else. And for any node that is stored inside ith index, it will have child nodes, left child at 2i plus 1 index, and it will have right child at 2i plus 2 index. Now things are easy, right? Don't need any class and anything. Just make an array and everything is done.
जैसे कोई नोड का एक ही चाइल्ड नोड हुआ
तो क्या होगा कि कुछ कन्वेंशन रख सकते हैं. Let's suppose this child node is not present. Let's suppose this child node is not present. So what can I do instead? We can just mark it by -1. That okay, this -1 will indicate that no child, no right child of 2 is there. Okay. Or we can simply assign it to be none. Now that's all. और तो कुछ problem नहीं है.
So repeat it again.
Okay, let's suppose okay, let's say this is the root. This is the root of my entire heap, of my entire main heap. Okay, this is placed at the 0th index. I want to have two child nodes of 1, 2 and 3. Where will I place it inside the array? 1 is placed at the 0th index of the array. So where will I place this 2 and 3 inside the array?
1 and 2. Index 1 and index 2.
At 2 into 0 plus 1 and at 2 into 0 plus 2, at these two indices. Getting it? Using this formula, I have to allot the indexes for the child nodes. Left child will be present where? 2 into 0 plus 1. Right child of node 1 will be present at 2 into 0 plus 2. So where is it going? Index 1 and index 2. Okay. 2 is here, 3 is here. Okay, fine. Now, okay, let's suppose I want to have left and right child of 2. I want to have left and right child of 2. 7, 9. Where should I place them inside the array? Where should I place them inside the array?
4 and index.
What is the index of it? Index is 1.
4.
Index is 1. So where should I place them? 2 into 1 plus 1 and 2 into 1 plus 2. So what are the values?
3 and 4.
3 and 4, right? 3 and 4. See at what index the parent is present. Parent is present at index 1. Multiply it by 2, add 1. Multiply it by 2, add 2. Left child will be present here. right child will be present here inside the array. Okay. Okay, now let's suppose this 3 should have a right child. This 3 should have a right child. This 3 should have a right child. Where the right child of 3 will be present? Where the right child of 3 will be present? What index inside the array?
6.
How? What is the index of 3? 2. Where should the right child be?
Sir, index 5 is null.
I plus 2.
2 into 2 plus 2, right?
2 plus 2.
So it is 6. So at the 6th index of the array, what will be there? 10. At the 6th index of the array, 10 will be kept. Why? 10 is the right child of 3. Getting it? This is how we make heaps using array. Arrays will be used to keep the heaps. All the data of the heap will be kept inside an array. And how they will be related? Which node is the child and child node of which parent? We mark it using index. If at index I, my parent is there, where the child nodes will be? At 2i plus 1 and 2i plus 2. 2i plus 1, left child will be there, and right child will be present at 2i plus 2. That's all. Nothing else here. Nothing else.
Got it, sir.
Any doubt? How will we store the data inside an array in heaps? Any doubt?
No, sir. All clear.
Any doubt till whatever we have discussed today? Please tell me. Else we will continue tomorrow.
No doubt, sir.
No, that's it.
Okay. Let's take the MCQs and we will wrap up today. I'm creating it. I've created the attendance also. Those who don't have any doubt, please mark your attendance. You can leave then.
MCQs.
दे दिया तो 4 MCQ दे दिए हैं. Very less people are attending these days. What is the problem? What is the issue?
सर MCQ शो नहीं हो रहे.
क्या बात कर रहे हो? 25 लोगों ने तो MCQs अटेम्प्ट कर ही लिया है.
पहले आया था, फिर रिलोड किया, अचानक 4 एक साथ आ गए.
हाँ ठीक है, जल्दी मार्क करो.
सर फर्स्ट क्वेश्चन मिस हो गया।
एक ही मिस हुआ ना? 3 कर दिया?
यस सर।
चलो ठीक है, अटेंडेंस मार्क करो फिर, कोई बात नहीं।
सर मुझे
Yes.
कोई स्क्रोल नहीं कर रहा है एमसीक्यू।
सेशन में करो, रिफ्रेश करो। अब तो और कोई फायदा भी नहीं, सब मिस हो गया। टिकट ट्रेस कर देना, ऐसा ऐसा इश्यू आया था।
हेलो सर।
बोलो।
सर एक बार शॉर्ट में एक बार कंप्लीट बाइनरी ट्री को एक्सप्लेन कर सकते हैं?
All the levels of the tree will be completely filled except the last level. यही complete binary tree का definition है।
तो सर परफेक्ट भी वैसे ही होता है ना?
परफेक्ट का लास्ट लेवल भी फुल फील्ड होता है, यही डिफरेंस होता है। ठीक है, कंप्लीट में लास्ट लेवल फिल हो भी सकता है, नहीं भी हो सकता है, पर परफेक्ट में क्या होगा, कंप्लीटली फिल्ड होगा। कंप्लीट में ना भी हो सकता है, परफेक्ट में जरूर होगा। ठीक है, ये डिफरेंस होता है। बोल सकते हैं
कंप्लीटली फिल्ड भी हीप हो सकता है ना?
कंप्लीटली फिल्ड ही हीप होता है। हीप होने के लिए कंप्लीटली फिल्ड होना जरूरी होता है, नहीं तो हीप हो ही नहीं सकते।
परफेक्टली फिल्ड सर।
परफेक्टली फिल्ड भी हो सकता है। परफेक्टली फिल्ड इज अ स्पेशल केस ऑफ कंप्लीटली फिल्ड, स्पेशल केस। ओके, who is having doubt, tell me। भाई अटेंडेंस मार्क किया या नहीं किसी ने?
Hello, sir.
बोलो। हेलो
Sir,
या
if time is there, can you explain the code for AVL tree?
okay, yeah, AVL tree I haven't touched it yet, just wait for that, but I don't think so in detail AVL tree is there inside your syllabus.
No, it wasn't
Okay,
there,
yeah,
sir.
I was planning for that also. In Saturdays if possible, in Saturday I will be taking the topic of AVL tree. Okay, this doubt session.
Okay, sir.
Okay, yeah, AVL tree is a vast topic, man, and this will be quite tougher if you, yeah, so that's why we'll take that on this Saturday. If I miss it this Saturday, I will be taking that on the next Saturday possibly, but we'll take that height balance BST.
Yeah, okay, sir. But
Okay,
if
yeah.
it's not on Sunday, it's better.
No, because there are a certain pattern, right? You have to go via that. So yeah, that in detail, if you want to get that in detail, come on Saturdays, then only we will discuss that. What is a BST, what is the AVL tree?
Yeah,
Okay,
that only balanced. Okay, sir.
yeah, sure.
Thank you, sir.
Yeah, thanks. Anything else? Any more doubts you are having? सौरभ कहाँ गया भाई, चला गया क्या?
यहीं पे हूँ सर।
क्या हाल है जनाब, बताओ।
आप सुनाओ।
सब सही भाई,
सब बढ़िया एकदम। एंड सेशन में मेरी याद जरूर आ जाती है आपको, क्या बात है।
यही बस आदत लग गई।
बुरी आदत मत लगाओ सर।
तुम्हें भी हमारी याद आएगी और कुछ दिनों।
इसीलिए तो बोल रहा हूँ बुरी आदत मत लगाओ।
नहीं यार, चलो तुम लोग तालमेल बैठ गया था। 3 months बहुत बड़ा टाइम होता है किसी भी बैच स्टूडेंट्स के साथ बिताना।
वो तो है। फर्स्ट टाइम बिता रहे हो क्या?
फर्स्ट टाइम इतना लॉन्ग किसी बैच के साथ जा रहा है।
अभी तो और बाकी है समय।
कुछ समय।
कितना टाइम गया है?
हाँ,
वैसे कितना टाइम गया है आपका मोस्टली लास्ट बैच में?
1 महीना, उससे ज्यादा नहीं। ओके, आफ्टर अटेन्यू आने के बाद पहली बार, मतलब इतना लॉन्ग टर्म किसी बैच के साथ मैंने बिताया है। दोस्ती टाइप्स हो गई।
तो हमारी बैच कैसी लगी आपको?
बहुत अच्छी यार, इसमें क्या है, हम कैसे लगे वो बताओ। तुम फीडबैक दोगे, मैं कुछ
सच में
थोड़ी ना
सर
बोलूंगा।
बहुत अच्छे लगे।
फीडबैक तो स्टूडेंट्स देते हैं ना कि सर अच्छा पढ़ाते हैं, बुरा पढ़ाते हैं।
वो चीजें अभी ना डिस्कस करें तो ज्यादा बेहतर है।
चलो सही, इनको बताना।
सर आपको कितना टाइम हो गया टेन्यू ज्वाइन किए?
3 महीना ऑलमोस्ट होते चला। तुम ही लोग मेरे फर्स्ट बैच हो अटेन्यू में।
अच्छा सर, आप जॉब भी करते हो?
जॉब भी करते हैं।
ये मत पूछना कहाँ करते हैं।
ये मत पूछना
कहाँ
कहाँ
करते
करते
हो?
हैं।
तो कहाँ करते हो?
किसी का फर्म में करते हैं, प्राइवेट फर्म में। क्या
ओके।
पूरा हिस्ट्री सर बता देंगे तो।
टीचिंग में मैं हूँ, ऑलमोस्ट 1 ईयर से मैं टीचिंग में हूँ, ये कह सकते हो। ठीक है, ऑलमोस्ट मैं 1 ईयर से टीचिंग कर रहा हूँ।
सर ग्रीक फॉर ग्रीक
सर
में
अब उसमें थे ना, अपग्रेड में थे ना?
नहीं ऐसा कुछ नहीं, अपग्रेड में मैं नहीं था।
और सर क्योंकि मैंने
दूसरे।
कुछ इन्फॉर्मेशन जाजिब सर से मिला था मुझे।
अच्छा, कहीं और पढ़ाते थे यार, ऐसे ही, ऐसा कुछ नहीं।
यूडेमी या फिर अपग्रेड, ये दोनों किसी में तो थे आप।
अच्छा चलो।
ग्रीक फॉर ग्रीक ग्रीक पे जॉबेथॉन आया है।
अच्छा करो फिर।
बहुत अच्छा है।
एक ही बात है, बैच के बाद, बैच खत्म हो जाने के बाद कोई नहीं डीए से प्रैक्टिस छोड़ेगा। जॉब
हाँ
तक, जब तक जॉब मिल जाए, जॉब के
सर
बाद
वो
भी कोई
गिग्स
नहीं छोड़ेगा।
पर गिग्स में हम लोग कुछ एडिट
आर्टिकल्स दे सकते हो वहां पे चाहे तो। ठीक है, आर्टिकल्स दिया जा सकता है।
मैंने कॉपी करके वीएस कोड में डाला ना, तो कोड एरर ही बता रहा था। उसका कंसोल में भी रन करके देखा तो वहां पे भी एरर दे रहा था। कोई एक कोड किया था, मैंने उसको नोटिस नहीं किया, लेकिन उसमें
देखना पड़ेगा कि क्या केस है। वैसे उनका तो मतलब, अच्छा वो जो कोड्स है वहां पे, उसके गिग्स फॉर गिग्स के आईडी आईडी में ही चलाया करो, बेहतर होता है। उनका खुद का कोड है, उनका आईडी फुल्ली सपोर्टिव होता है उसके लिए। चलो सही, गुड नाइट ऑल ऑफ यू।
गुड नाइट सर।
सर
गुड नाइट।